Hello, I'm FC Lee's AI avatar. Welcome to the Video User's Manual for FC's Tech Bench, brought to you by FC's Slot Stuff, 1/32nd scale slot car parts and accessories. Be sure to visit us online at FCSLOTSTUFF.com. In today's video, we'll be covering the following topics. 1. What's in the box? 2. Care and maintenance. 3. Specs and details. 4. General use. 5. Windows software download and installation. As we progress through the sections, we'll add a small chapter marker at the top left of the video to help you keep track of what section we are currently on. First up is what's in the box. To confirm which version of the Tech Bench you purchased, look for a white square on the box's label. If checked, this means you've got a controller version. If empty, you've got a standard version. On the top of the box is a QR code. Scanning this QR code with your phone's camera or barcode scanner app will bring you here to this video instruction manual on YouTube. When opening the Tech Bench box with a blade, knife, or scissors, be careful not to dig in too deep to ensure you don't damage the contents. In the box, you'll find the Tech Bench, standard or controller version, a pair of 4mm banana plugs for use powering external tools with the Tech Bench's power module, 2 car stops used to hold your cars in place when on the Tech Bench, an FC's SLOTSTUFF sticker, and a 12-volt grounded DC power supply to power your Tech Bench. Next up is Chapter 2, Care and Maintenance. Keeping the Tech Bench well-maintained is key to its reliable operation and isn't that hard to do. When cleaning the surfaces of the Tech Bench, use Windex or a mild soap and water solution only. Other cleaners may harm or damage the Tech Bench or its displays. Spray cleaners onto a microfiber towel and use that to wipe down the Tech Bench. Remember to never spray cleaners directly onto the Tech Bench. The Tech Bench's roller should be inspected periodically to ensure it is clean and free of dirt and debris, using the same damp cloth cleaning method described earlier in this section. Any residue on the roller may interfere with the RPM sensor's ability to provide accurate readings. If you find that the roller is not spinning freely and requires lubrication, a very small application of WD-40 spray oil on each bearing will resolve the issue. Be sure not to overdo it and immediately clean up any excess oil on the Tech Bench and roller. Note that other oils have not been tested and are not recommended as they may damage the roller's finish or bind the bearings over time. Inspect the reflective marker on the roller and ensure it is clean and undamaged. Should you need to replace it, any 1/16" reflective pinstripe tape will suffice. For a direct OEM replacement, use ChartPack Graphic Arts tape in Mylar. Lastly, remember to always handle the Tech Bench with care. Don't drop it or handle it roughly. Chapter 3, Specs and Details. Right now, we're going to talk a little bit about the specs of the Tech Bench, how it came to be, and later, we'll go into its use. The Tech Bench is the result of about 2.5 years of research and development. As a slot racer, I was really curious about how differences in setup, including motors, gears, tires, and wheels, affected the handling and performance of my cars. I started out by looking into tools that might already exist, and while I did find a few things, all of them were either discontinued and hard to find, or just really didn't do all the things I wanted. So I started working on sourcing and finding parts that were readily available, were fit for purpose, and did the things that I wanted in order to build my own solution. During this process, I had great support from a few close slot racer friends, and I want to thank those early adopters who took a chance to buy a prototype and started playing with them early on. Mike, Al, Dave, and more recently, John and Daniel. Thanks so much for your support and encouragement, your feedback, and for your assistance in getting the tech bench up and running. I also want to send a special shout out to my friend Rich over at Great Traditions for his continued support of FC's Slot Stuff, and a big thank you to all my racing buddies at Wednesday Night Racers in Philadelphia for helping to make the middle of the week something to look forward to. Okay, now back to specs. The tech bench comes in two versions. The standard version allows you to use the onboard power module to control power to the car. The controller version adds the ability to plug in a controller and see how your car and controller work together. The tech bench works with both 1/24th and 1/32nd scale cars. Let's start highlighting the features of the tech bench. We'll start with the 20mm balanced aluminum roller that is mounted on two high-speed ball bearings and a 5mm hardened lathe stock axle. This makes the ride smooth and quiet. The benefit of this feature is the ability to visibly detect problems with your car's drivetrain when running your car at low voltages. By the way, the tech bench allows you to run your car at any voltage from 0.6 of a volt all the way up to 36.5 volts. When you run your car at low voltage, you'll be able to see whether or not there's any problems in your drivetrain. Maybe you have, and this has happened to me, some wheels that are bent or out of alignment that you don't see when you're running the car at speed. You may wonder why the car isn't performing right, but not really see a problem on the track. If you put it on the tech bench and run it at low speed, you'll be able to diagnose issues like this. Suddenly you say, oh, I have either a screwed up axle or maybe an aluminum wheel that's warped or a tire that's not seated properly. The tech bench points it out so you can fix it. So it's great for diagnostics in these situations. In addition to its benefits as a diagnostics tool, the balanced roller also means you're able to get reliable readings as well from an RPM perspective. On the roller, you'll see a reflective strip. This is used by the tech bench to measure the roller's rotation and your car's RPM. This strip can also be used by an external laser tachometer if you wish to review or double-check the tech bench's readings. Now, I do want to note that this isn't a dynamometer. It is a tachometer and rolling bench. The reason for this distinction is that a dynamometer will provide you with torque readings as well. Now, the tech bench doesn't give you the ability to obtain a torque reading, but there are ways for you to test your car and derive useful information about its acceleration and braking torque performance. You can obtain this information by extrapolating time to full speed and to full stop, or via calculation of the mechanical and electrical properties of your car using FC's Tech Bench AI Performance Assistant. These are readings where the wheels, tires, motor, and gearing are all factors. So there's the ability for you to use the tech bench to obtain some torque performance information from your setups via charting or AI assistant analysis. I'll talk a little bit about that as I roll down through the features here, and then obviously we'll get into a demonstration of the unit as well. Getting back to the top of the tech bench, in addition to the roller, there are two nickel power rails, a deep slot large enough to accommodate all modern guide flags, and two channels used to hold the tech bench's car stop in place. Moving over to the left side, Both TechBench versions contain positive and negative 4mm banana plug jacks, so you can use your TechBench as a standalone power supply for external tools, and the TechBench's on-off rocker switch. For the controller version, this side is also home to the controller override plug, which slides into the red, black, and white controller slots that also reside on this side of the TechBench. Note that this plug can only fit one way. It's designed like this in order to prevent you from plugging it in incorrectly. Now let's look at the back of the TechBench. Power is provided using a 5.5mm by 2.1mm DC plug, and the TechBench comes with a 12-volt grounded power supply included. You can also use any 9 to 30-volt DC power supply or battery to power the TechBench if you have that 5.5mm, 2.1mm DC plug connected. The power to the TechBench must be 9 volts or above for it to work properly. I should also mention that current draw limitations make using low-capacity batteries, like standard 9-volt batteries, unreliable for use with the TechBench. Also in the back is the USB-C connection. This allows you to connect the TechBench to any recent Windows-based computer to either monitor or capture data for charting and analysis. Systems on Windows 10 or above will allow you to interface with the TechBench without the need for additional drivers or setup, making it completely plug-and-play. The TechBench's onboard display and included Windows software will show you RPM, voltage, and current readings once per second, but when capturing data via USB-C input, the TechBench will output 15 to 20 readings per second. It does this in order to provide you with more granular detail on your car's performance when using the TechBench for charting and analysis. Both of the TechBench's onboard displays have a timeout of 4 minutes. This saves power when running the TechBench with a battery, and it also prevents the screens from getting burn-in, a condition that degrades the quality of the displays over time. After 4 minutes of no button input, the left power module screen will time out. Using the power module knob or button will restore the power module screen's display. The right car data display will time out after 4 minutes if it senses no RPM information coming in from the roller. Registering an RPM value will restore the car data screen's display. In the event the car data display does not restore with RPM activity, simply power the TechBench off and on again to reset the display. From a processor perspective, the TechBench features a 32-bit RISC-V single-core processor running at 160 MHz, and it's one of the faster processors currently available at this particular size and cost. Both the TechBench's onboard and Windows-based software were created using artificial intelligence. I know AI is a bad word in this day and age, but it's really a very, very useful tool. The software includes an algorithm that adjusts the sensor sample rate to maintain accuracy across the entire RPM range based on the current speed of your car. So what that basically means is the TechBench checks to see how fast the last sensor reading was and adjusts its sample rate based upon processor load and how hard it's working to display and send output to the screen and serial port. It does these calculations and adjustments on the fly, so it continues to take accurate readings while still giving you quick responses back, with all critical calculations being performed inside the code's interrupt loop, not the main loop. This is key to the TechBench's ability to provide accurate readings quickly. Performing calculations in the interrupt loop is really not a software development best practice, but processing this way allows the TechBench to grab and report an accurate RPM reading after only 2 rotations of the roller. It does this by calculating RPM using the time between full rotations instead of a count of rotations over time. So by the 3rd revolution, you're able to see the actual RPM of your car. The TechBench gives you this information without having to wait, and in addition, this behavior is necessary when you're capturing data for charting and analysis of your car's performance. Each TechBench is assembled and calibrated by me, and it doesn't leave unless the accuracy of the unit is within plus or minus 10 RPM on a 10,000 RPM reading when comparing the TechBench against a laser tachometer. This is a standard deviation of 0.058%, which in scientific terms is considered accurate enough for high-precision applications. Bottom line is that I want to make sure that the tech bench is collecting the most accurate information it can. The caveat here is that any calibrated reading is only as good as the accuracy of the control device, in this case a laser tachometer. That being said, having two separate instruments return the same value is a good thing. Next up is noise reduction. Our DC slot car motors can sometimes produce a lot of noise by way of flyback current, high-frequency noise, and EMFs. To ensure that this noise doesn't affect the tech bench's readings or damage its processor or your computer, I've equipped the tech bench with 3 stages of noise reduction and power protection. First, a fast-acting Schottky diode ensures flyback voltage during braking and stops does not dump back into the system through the power lines. This diode allows positive current to pass, but clamps down immediately if negative current is detected. Next up is a 3-part capacitor noise reduction power conditioning section. This stage uses 3 separate capacitors in parallel to smooth out high-frequency noise in 3 different overlapping ranges on the power lines. The capacitors were selected based on oscilloscope readings of many popular slot car motors and the noise they produce. Next up on noise reduction is a high-frequency ferrite core choke attached to the main power lines to soak up any remaining residual noise on the line. Finally, ground-shielded wiring is used between the power supply and car, with a ground wire dumping out any remaining noise back to the main power ground. The power module inside the tech bench is a full-feature power controller that contains a number of built-in protections that help make the tech bench safe to use. Among these protections are the ability to have the power module shut power down to the tech bench in the event of shorts, power, current, voltage, or temperature surges, and to limit runtime based on a predefined maximum runtime setting. All of these settings are configurable and can be saved in one of 10 memory locations for recall and use. While these protections help make the tech bench safe and reliable, it's important to make sure that you fully understand how each one operates and never leave the tech bench unattended when in use. The maximum runtime and voltage settings on the power module allow you to set a voltage value and time to run that in combination can be used to have the tech bench break in your motors under load for a predefined period of time. Once the maximum defined time limit is hit, the tech bench will automatically turn power off. Okay, that concludes this high-level roll-up of all the tech bench's features. Stay tuned next for a hands-on tutorial on its use. Chapter 4. General Use. We're going to start this section with a detailed review of the tech bench's power module. It's the interface you'll use to power your cars and attached peripherals, and understanding its use, capabilities, and protections is key to helping you get the most out of the tech bench. The power module is pretty simple to operate, and once you understand its operation, intuitive too. The power module contains 2 simple inputs, a silver push-to-select rotary knob and a yellow on-off power button. Most activities such as option selections, voltage setting, etc. are performed by the push-to-select rotary knob. On any of the power module's 5 screens, short pressing the knob initiates the option selection routine for all available values on that screen. Once in the option selection mode, twisting the knob left or right will navigate you through all the other selectable fields available on the screen. When a field is highlighted, short pressing the knob again will allow you to select that field and cycle through the available options for it. When you've found and made your selection, long pressing the knob or no activity for 5 seconds will lock in your selection. Now that we know how to use the power module's interface, let's dive into its other screens and options. Across the top of the power module's display, left to right, is a green sun icon, a series of 4 small and 1 large green dots, and the currently selected memory location in use by the power module. Each of the 5 dots shown at the top represent a separate power module screen, with the larger dot representing the current screen displayed. If the leftmost dot is not the largest, turn the knob left or right until it is. This is the main operation screen of the power module. This screen will show you on the left, current active voltage value, current active amperage value, current active wattage value. On the right, the unit's current temperature in Celsius or Fahrenheit, the current operating mode of the power module. There are two modes. First is CV. This stands for controlling voltage and is the default mode used with the tech bench. In this mode, you specify a voltage value for the power module to provide, and the current drawn by your car is not limited. The second mode is CC. This stands for controlling current. In this mode, you specify a current limit for the power module to provide, and it will not allow your car to pull more than that current. Below the operating mode indicator is the on-off indicator. This will be on when you provide power to your cars with the yellow on-off button. Across the bottom of the main screen, left to right, you'll see Set, used to set the voltage you want to use to power your cars, and to the right, Amperage, used to set the amperage. On the power module, short press the Push to Select rotary knob. You should now see a blue bar highlighting either the entire voltage value or one of the individual voltage values. If you see a blue bar around the entire voltage value, short press the knob one more time to go into voltage selection mode. In voltage selection mode, you should now see the 1/100th of a volt value highlighted in blue. If you'd like to set that value, turn the knob until you reach the value you want. If you wish to set voltage in increments of 1/10th of a volt as well, short press the knob again until you see the 1/10th value highlighted in blue. Turn the knob again until you reach your desired value. You can continue to do this across all the on-screen voltage values until you reach your desired setting. Once done, long press the knob or simply wait 5 seconds for the tech bench to accept your input and return to screen display mode. As just mentioned, when the power module is in value selection mode on any screen, it will revert back to screen display mode if it does not sense movement within 5 seconds. If that happens, you'll have to restart the selection process again if you have not completed entering your desired voltage setting. Now that we're done selecting our voltage values, let's have a look at the power module's other screens. Moving the knob to the right brings us to screen 2. On this screen, you'll see the following values. In green, amp hours. This is how many amps per hour the unit has provided from power on to power off. In yellow, watt hours. This is how many watts per hour the unit has provided from power on to power off. Next in white is the total time in operation from power on to power off. When using the tech bench to break in your cars, this value is where you will look to see how much time has elapsed in your break-in routine. Below time in use in red is the input voltage being provided to the power module by the DC power supply or battery currently attached to the tech bench. Finally, across the bottom of the screen are the current output voltage and amperage being supplied by the power module. Moving the knob to the right again brings us to screen 3. On this screen, you'll see a chart of current voltage and amperage use, as well as the highest and lowest voltage and amperage used by the tech bench from the time it was last powered on. High and low voltages are on the left of the chart in yellow, top high, bottom low, and the current values are on the right of the chart in blue, top high, bottom low. This information is only present when the power module is in use. Moving right again, screen 4 shows all the protection parameters you can set for the tech bench's power supply. First up, MPRE. This stands for Memory Preset. The power module comes with 10 memory locations. These memory locations are labeled M0 through M9 and allow you to set up unique power profiles for use with different scale-size cars or set up different voltage and time limit break-in routines. For example, you can set up a memory location with a default voltage of 6 volts and a default runtime of 30 minutes. You can then recall this memory location anytime you wish to break in a car at 6 volts for 30 minutes. The MPRE value here is for memory location 0 and allows you to set the default power-on behavior for the tech bench's power module for that memory slot. When set to off, recalling the specified memory location will not power on the tech bench automatically. If set to on, the power module will automatically turn on without the use of the yellow power button when you recall the specified memory location. Let's explore the rest of the available power module protection parameters on this screen. All settings from this point forward will pertain to the memory location specified in the MPRE setting. Next is VSET. This sets the default voltage value for the MPRE memory location specified. Below that is ISET. This sets the default maximum amperage value for the MPRE memory location. You can leave this at 5.1 amps unless you wish to restrict the maximum amperage provided by the tech bench. Next is SLVP. This stands for Low Voltage Protection and defines a minimum input voltage required to power the tech bench. In this case, a minimum voltage of 9 volts is required to run the tech bench, so it's appropriate to set this value to 9 volts. In the event you try to power the tech bench on using less than 9 volts into the power module, it will shut down and display an error. Next up is SOVP. This stands for Over Voltage Protection and defines the maximum output voltage the power module will provide before shutting down. If you wish to ensure you never send more than 15 volts to the power rails of the tech bench, set this value to 15 volts. In the event you try to go above this value during tech bench operation, the power module will shut down and display an error. Next is SOCP. This is a very important protection setting on the power module. It stands for Overcurrent Protection and is used to limit the output amperage you wish the power module to provide. It is recommended that you set this value to 2 amps. With this in place, the power module will display an error and shut down power to the tech bench in the event of a power short. Again, this is a very important protection against fire or damage to the tech bench and your cars. Next is SOPP. It stands for Overpower Protection and is similar to the SOCP option above it. If you wish to set your current limit in watts instead of amps, you can use this setting. If you've already set the SOCP parameter above it, you can simply bypass setting this value. Next is SOTP. It stands for Over Temperature Protection and is used to set a threshold temperature value in Fahrenheit or Celsius to protect the power module from overheating. If the power module's temperature rises above this value, the power module will display an error and shut output power off. It is recommended that you set this value to its lowest setting. For Fahrenheit, this is 140 degrees. Next is another important value for the tech bench, SOHP. This stands for Over-Hour Protection and is used to set a maximum runtime for the tech bench. When this value is set, the tech bench will run only for the amount of time specified here and power off when this time limit is hit. This is the parameter you will set when you wish to perform timed break-ins of your cars with the tech bench. Setting this value to 0 means the tech bench will not power off automatically. Next is SOAH, and it stands for Overamp Hours. It is used to limit and turn off the tech bench when a specific amp-hour threshold is hit. This parameter is generally not used with the tech bench. Finally, SOWH stands for Over Watt Hours. It is used to limit and turn off the tech bench when a specific watt-hour threshold is hit. This setting is also generally not used with the tech bench. That's it for Screen 4. Let's move on to our last power module screen, Screen 5. Screen 5 contains power module display options. First is BL, the power module's brightness level setting. This option's values range from B0 to B5. B0 is the darkest, B5 the brightest. I personally prefer brightness level 5, but the power module will default to BL3 if reset. On the right of BL is a small clock icon. This sets the screen timeout in minutes. I default this value to 4 minutes to match the tech bench's car display screen timeout. Next is temperature value and offset. Here, you can select the default temperature scale to use with the tech bench, Fahrenheit or Celsius, and also specify a temperature deviation value when comparing the power module's temperature against the actual temperature in your work area. This is helpful if you find the power module's temperature reading is significantly different than the actual temperature in your work area, and adding a value here allows you to ensure that the temperature protection settings you specified on Screen 4 are accurately triggered. Skipping the next line, we'll move to the OH Clear option. Values are yes or no. Selecting yes appears to not do anything. Next is R. This is a factory reset of the power module. Values are yes or no. Yes will reset the entire power module. No will return you back to screen 5. Note that if you reset the power module, all previously set power protection parameters and memory locations will be erased and will need to be re-entered. The next 3 rows on screen 5 allow you to change the color scheme of the power module's screens, while the bottom on off option appears to have no effect on any visible settings used by the tech bench. Finally, remember those memory locations I mentioned earlier? Well, in order to call up a memory location for use, simply press and hold the knob for 3 seconds. This will bring up a call-out prompt screen. Rotating the knob on this screen will cycle through the available M1 through M9 memory settings. And while a memory location is displayed, pressing the knob again will load in that memory location's settings. I found a bug here I want to share. It appears that you can never select memory location 0 using the call-out memory recall routine. With this in mind, it's recommended that you do not add settings to M0 or only use M0 if you're not intending to save and use multiple memory locations. Now that we've gone over the power module, its options, and how to use it, let's get a car on the tech bench and take our first readings. We'll start with the standard version. I want to mention here that the controller version of the tech bench will operate exactly the same way as the standard version when the controller override plug is in place. Let's first make sure we are on screen 1 on the power module's display. Next, place your car on the tech bench and position the rear wheels just left of center of the roller. When placed properly, the car would roll forward if the car stop was not in place. While holding the car in this position, take one of the 2 provided car stops and insert it into the top of the tech bench so that it is in contact with the front of your car. When positioned properly, the car will remain in place after you remove your hand. With the car in place, press the yellow power button. The power module will send the previously set voltage to the power rails, and your car will start running. You should now see values in the voltage, current, and watt fields on the power module's display. Moving over to the car display screen, the tech bench will start displaying the car's current RPM or revolutions per minute, FPS, which stands for feet per second, and MPH or miles per hour. These readings are taken at the wheel of your car and are based on the 20mm diameter of the tech bench's roller. For each rotation of the tech bench's roller, your car will travel 62.83 millimeters in distance. Under the speed values on the car display screen, you will also see the voltage and current power draw readings of your car, including bus voltage. This is the voltage the power module is providing to the tech bench's power rails. Load voltage. This is the voltage actually drawn and used by your car. Current, your car's current draw in amps. And finally, power, your car's current draw in watts. By now, you should have noticed that the voltage and current values on the car display screen vary slightly from the power module's readings. This is because the voltage and current readings on the car display screen are based on your car's usage, while the power module's readings are based on the voltage and current it is providing. With that in mind, it is recommended that you use the load voltage value on the car display screen as the reference point when setting your desired operating voltage. As an example, if you wish to see how your car behaves at 6 volts, you should adjust the power module voltage value until the load voltage value on the car display screen shows 6 volts with your car running. You can adjust voltage on the power module at any time with power on or off. Please note that if you are raising the voltage value while the power module is on, it will not initiate the overvoltage protection setting if you go above your OVP overvolt protection threshold, as it considers your active change under operation to be an intentional override of that setting. If you set a voltage value above the OVP threshold when the power module is off, the overvoltage protection threshold will be respected during your next power on. Okay, back to our car. With the car running, feel free to use the power module knob to cycle through its second and third screens to review the information and charting that is displayed while the tech bench is in use. One more thing to consider. When turning off power to your car while it is on the tech bench, it's recommended that you be ready to grab your car from the rear as it decelerates. When using the tech bench to brake cars in, or if using the controller version of the tech bench, it is recommended that you place a small piece of tape or paper around your guide flag to hold your car in place on the tech bench so it will not roll off the back when the break-in time period ends, or when you apply brakes from your controller. If you wish to use the tech bench's power module as a standalone power supply, remove any cars from the top of the tech bench and connect the included positive and negative banana plugs into the jacks on the left-hand side. Connect the other end to your external tool of choice. Enter your desired voltage and/or other power settings on the power module and hit the yellow Power On button to power up your tool. That covers the general use of the standard tech bench version and the controller version with the controller override plug in place. Next up, we'll talk about using the tech bench controller version with a controller. First, power off the tech bench with the left side power switch and remove the controller override plug, also on the left side of the tech bench. This will expose the red, white, and black controller hookup plugs for use. Clip or plug your controller to the tech bench and verify each clip or plug color matches the appropriate color marked on the tech bench's controller hookup. Now turn the unit back on. Place your car on the tech bench and set the car stop using the previously mentioned method. Also, as previously mentioned, add a small piece of tape or paper to the guide flag to hold your car in place and prevent it from rolling backwards off the tech bench during braking and stops. Next, set your desired voltage on the power module. If you typically run 12 volts on your track, set that voltage value on the power module and press the yellow power button to turn on power to your controller. You are now ready to control the acceleration and braking of your car using your controller. Note that all of your controller's functions will operate the same way on the tech bench as they would on your track, and all readings on the car display screen will be based on the current position of your controller's trigger. Slowly press the trigger and watch your car accelerate. Releasing your trigger will engage braking in line with your controller's current brake settings. You can use this setup to better understand the dynamics of how your various cars interact with your controllers and their settings. You can also use it to troubleshoot, chart, test, and generally confirm the performance and operation of your cars, controllers, or both in combination. When you are finished using the tech bench with your controller, use the yellow power button on the control module to turn power off. Next, disconnect your controller, power off the tech bench with the left power toggle switch, and insert the controller override plug back into the tech bench. Note that the plug only goes in one way. This is by design and prevents you from accidentally inserting the plug the wrong way. That covers the operation of the tech bench, both standard and controller versions. Chapter 5: Software Download and Installation. Now that we've gone over the tech bench's general use, let's download the included Windows Tech Bench dashboard software so that we can interface the tech bench with your Windows computer. To start, open a browser and navigate to FCSLOTSTUFF.com. Once there, look for the Store menu option at the top and select Product Categories. On the next screen, the top left category will be Software Downloads. Click that, and you'll see the Tech Bench software download. Select that, add it to your bag, and in the checkout, put in your email address and click Checkout. After checking out, click Place Order, and you'll see a link on the next page to download FC's Tech Bench dashboard. Click that link, and the software will be downloaded to your system. Next, navigate to the directory on your system that the file was saved to, and double-click it to start the installation. Click Run, and the installation process will start. If you wish to create a desktop shortcut, you can do so here. And finally, if you wish to launch it immediately, click the appropriate checkbox and finish. If you kept the Run Immediately checkbox ticked, FC's TechBench Software Monitor 1.0 will come up. Next, using a standard USB to USB-C cable, connect your TechBench to your computer and wait for it to be recognized. You will usually hear a sound like a ding when your hardware manager has completed setting up the device for use. Once you hear the ding or receive other confirmation that the new hardware is installed, click the Scan Port button on the top left of the TechBench dashboard screen. The scan should display the latest port added to your computer, which in this case is the port you just plugged the TechBench into. Next, click Connect, and you'll notice the TechBench will reboot, bringing up the car display splash screen. Once finished rebooting, you'll see zeros displaying for most values on the dashboard screen. As you start to use the TechBench, you'll be able to monitor your car's readings on both your computer screen and the TechBench's car display screen. The TechBench's dashboard software comes with a few added features. First, the TechBench dashboard adds kph, or kilometers per hour, to the list of previously mentioned values it displays. In addition, the TechBench dashboard software comes with its own proprietary speed estimator functionality. This added feature allows you to estimate both your motor's current RPM reading and your car's RPM at the wheels when using a different pinion and spur gear combination. The speed estimator functionality can be found at the bottom of the TechBench's dashboard screen. The left side portion of the speed estimator gives you the ability to see your car motor's current RPM reading simply by entering your current pinion and spur gear teeth count. The motor RPM reading will start when you select both pinion and spur values on the left side of the speed estimator. While the left portion of the speed estimator is displaying your motor's current RPM, entering a desired pinion and spur gear count on the right side of the speed estimator will start displaying the estimated RPM of your car at the wheels if you had that gear ratio installed in your car. This is a useful tool to determine how gear ratio differences will affect your top speed, and when charting your car's performance, you can also determine how gear changes will affect your car's acceleration and braking performance. And all of these calculations are done in real time as your car is running. Next up, we'll install the Data Streamer add-in for MS Excel and perform a quick connection and data capture using the TechBench. First, disconnect the TechBench from the TechBench dashboard if already connected. Next, bring up a browser and search for Data Streamer Download. In the search results, find the link for the official Microsoft download site and click it. Once there, locate the download button for Microsoft Data Streamer and click that to download the add-in into your system. Once downloaded, navigate to your download directory and unzip the file. Next, go to the directory Data Streamer was unzipped to and select setup.exe to run the setup program. Once complete, open up an instance of Microsoft Excel. In Excel, select File and Options at the bottom left of the screen, and then select Add-ins. Once in Add-ins, go to the bottom and select Manage COM Add-ins, and click Go. From here, select Microsoft Data Streamer for Excel and click the checkbox. When you click OK, you should see a new Data Streamer menu option pop up on Excel's ribbon menu. With the TechBench powered on and connected to your computer, select the Connect a Device option. Once in the drop-down, locate and select the COM port associated with the TechBench. Once selected, you should see the TechBench reboot as it had before when you connected it to the TechBench dashboard software. After the reboot, the TechBench will be connected to Excel and is ready to start streaming data for charting. Once you are connected, from the Excel Data Streamer menu, select Start Data and then Record Data. Excel's Data Streamer add-in will now start collecting streaming information from your TechBench. On the TechBench's Power module, hit the yellow on-off button to start power to your car, and Excel will begin capturing the TechBench's readings. By default, the Data Streamer add-in is set up to only collect 15 rows of data. However, you can adjust the number of rows captured elsewhere in Excel's Data Streamer worksheets. When you are finished capturing data, hit the yellow power button on the TechBench's power module again to stop power to your car. Next, from the Data Streamer menu in Excel, select Stop Data. Here, Excel will prompt you to name your streaming data output file. Once finished, from the Data Streamer menu, select Stop Recording. And finally, Disconnect Device. You can now use the captured data to chart your car and/or controller's performance using Excel. If you wanted to go deeper with the analysis of your car's performance, you can also try the soon-to-be-released TechBench AI Assistant. The AI Assistant will guide you step by step through the deep analysis of your car's performance, and when finished, provide you with a full report of your car's performance. I'll be doing a separate video on capturing and charting TechBench data with Excel and the AI Assistant in the near future. In the meantime, feel free to refer to the Data Streamer documentation for more details on its use. This has been the Video User's Manual for FC's TechBench. If you've already purchased a TechBench, please accept my sincerest thanks. I hope you find it an invaluable tool in the setup, diagnosis, and analysis of your slot cars and controllers. Please visit us on the web at FCSLOTSTUFF.com, or for questions or inquiries, contact me directly at FCSLOTSTUFF@gmail.com. I'm FC Lee. Thank you for watching.